Okay, hello everyone. Thanks for joining me. Anyway, we're going to continue with Chapter 6. I wanted to go through lots of nomenclature examples, and so I'd like to finish up the homework. Unfortunately, I don't have a tablet or I don't have an input device, so writing is going to be very slow. So I'm going to skip the writing and just say the answers verbally, and then you can check those at your leisure. Anyway, let's get started here. I think we left off with number 10, if I recall, O2. O2's oxygen. Ca would be calcium, Ba, barium, Ag, silver. So we have three metals, calcium, barium, and silver, and one non-metal diatomic element. Okay, number 11, we have carbon, silicon, tin, and lead. And here are samples in the photograph shown here, but carbon would be just C, silicon Si, tin Sn, and lead Pb. All these are solid. Okay, then let's check the answer. Just C, Si, Sn, and Pb. We have chlorine. Chlorine is a diatomic element. We just memorized that. So we would say Cl2 if we're talking just about chlorine, the element. However, we could also be talking about atomic chlorine, which would just be Cl. And so again, it's not entirely clear if we're talking about Cl or Cl2. Mg for magnesium. Nitrogen is a diatomic element as well, and here we could be talking about N2, which would be the element nitrogen, which is what you're breathing now. Or it could be, for example, a nitrogen-containing compound, like we were talking about nitrogen monoxide or nitrogen dioxide. There's no N2 gas in those. It's just nitrogen is incorporated into the molecule with oxygen. Vanadium is a metal, V. Okay, let's continue on here. I have to move this over so I can go to the next problem. Number 13, oops, showed the answer here, but let's cover that up. A dichlorine monoxide, again, binary molecular compound. This is a compound made up of two nonmetals. With dichlorine, which means two chlorines, and monoxide is one oxygen, so Cl2O. Tribromine octoxide, three bromines, 8 oxygens, and so that would be Br3O8. HBr. HBr begins with an H, so normally we think acid. However, this is in the gaseous state, so we'll name this as an ionic compound. It would be hydrogen bromide, or we could name this as an acid. An acid, it would be hydrobromic acid, or I guess if you follow the rules for binary molecular compounds, it could be hydrogen monobromide. Something of that sort. And then we have P2O3, 2 phosphorus, which would be diphosphorus, 3 oxygens, trioxide. So let's check our answers. Cl2O, Br3O8, hydrogen bromide, and diphosphorus trioxide. Again, if the HBr were AQ, I would have called this hydrobromic acid, but since the HBr is gas, we'll call it hydrogen bromide. Okay, then 14, CCl4, binary molecular compound, once again, 2 nonmetals, carbon and chlorine. So this would be carbon tetrachloride, tetra for 4. CBr4, again, binary molecular compound, would be carbon tetrabromide. NO would be nitrogen monoxide or nitric oxide. Dinitrogen monoxide would be N2O, also known as nitrous oxide. So we have nitric oxide, nitrous oxide. Sulfur dioxide would be SO2, and sulfur hexafluoride would be SF6. Okay. All right, let's move on to number 15. Number 15, explain how monatomic anions are formed from atoms in terms of protons and electrons. And so we could pick a specific example, for example, fluorine. Fluorine forms a monatomic anion called fluoride, has a -1 charge. And so basically fluorine has 9 protons and 9 electrons, If that fluorine atom gains 1 electron, it would form fluoride. Fluoride would have 9 protons and 10 electrons. Having 9 positive charges and 10 negative charges will get a net negative 1 charge, which is what we see for fluorine going to fluoride. Let's see the book's answer. When an atom gains electrons, the particle that results is monatomic anion. The ion has a negative charge because it has more electrons than protons, so an imbalance there. More negative charges than positive charges. 16. Write an equation that shows the formation of rubidium ion from neutral rubidium atom. Okay, here the equation would just be Rb. You could put solid there, or we could just leave it as Rb. Rb goes to, that is, we'd write an arrow. That would go to Rb with a positive charge, so we put the superscript plus on there, plus an electron. An electron would have a superscript minus, and so we've lost an electron. If we lose an electron, we're going to have more protons than electrons, which forms a cation. 17. What are the formulas of the lithium ion? Lithium is a group 1, and all group 1 ions are +1, so that would be +1, except for hydrogen. Hydrogen could be +1 or -1. And then the nitride ion. Nitrogen, okay, if fluorine forms fluoride, which is -1, oxygen forms oxide, -2, nitrogen is going to form nitride, which is -3, so it should be N superscript 3 minus. So N superscript 3 minus, and Li was plus. Okay. That's a nitride ion, the lithium ion. What are the names of O2 minus? O2 minus is monatomic, so it has the IDE ending. So it's oxygen with an IDE ending, which would be oxide. Iodine is another monatomic anion. Its ending is going to end in IDE, ide. And so this would be iodide, oxide and iodide. Those are the two there. Okay, let's move on here to the next set. Actually, that didn't go forward. Let me try that one more time. Here, there it goes. All right, what are the formulas of cobalt-3? Okay, cobalt-3 is a variable charge, and the charge we see by the Roman numeral 3, so it's CO, that's a uppercase C, lowercase o, with a 3+ charge as a superscript. Aluminum ion is fixed charge at 3+. What are the names of Fe3+? Well, Fe is variable charge, so that would be iron, parentheses, Roman numeral 3, close parentheses, and Hg2, 2+. Okay, that's the polyatomic that we memorized. That's called mercury, Roman numeral 1 in parentheses, all one word. So let's check the answers here. We got CO3+, Al3+ for the cobalt-3 and the aluminum ion. And then we have the iron 3 ion, iron Roman numeral 3, and the mercury 1 ion, Hg2, 2+. Okay, what are the formulas of tin-4? Well, tin is Sn, and the charge is 4, so we do Sn4+. And then manganese 3, manganese is variable charge as well. This would be Mn, the symbol, with a 3+ charge. What are the names of Pb2+? Pb is a variable charge, it's a 2,4 ion, so this would be lead-2 ion, or plumeless ion, and then cobalt. Cobalt is a 2,3, and so this is the 2, which is lower charge, and so this would be cobalt, Roman numeral 2, in parentheses, or cobaltus, okay, ion. Let's see, okay, let's move on here. Next page, here we go, okay, 21. What are the formulas of nickel-3 oxide? So we got nickel with a 3+ charge, and then oxide with a 2- charge. And so to balance this out, we're going to need 3 oxides and 2 nickels. So it'd be Ni2O3. And then we have cobalt-2 chloride. Chloride is a -1, so it would be CO, Cl2, should balance out the charge. Silver sulfide, silver is fixed at +1, sulfide is a -2, and so this would be Ag2S. And then finally mercury 2 iodide. Mercury is at +2 and iodide is a -1, so it'd be Hgi2. Now mercury 2 is different than mercury 1. Mercury 1 is a diatomic ion. Mercury 2 is a monatomic ion. So let's take a look at these. So we have Ni2O3, COCl2, Ag2S, and HgI2. Okay, what are the formulas of lithium nitride? Okay, lithium is a +1, nitride, as we saw earlier, is an N3-. So we'll need 3 of the positive lithiums to balance out the nitride. That would be Li3N. Chromium 2 chloride. Okay, chromium is +2, and chloride's a -1, so we'll need 2 chlorides. So this would be CrCl2. Aluminum phosphide. Phosphide is right underneath nitride, and so phosphide would be a P3-. Aluminum is an Al3+, so it just balances out. And so we just need a 1-to-1 Al-P. That's it. And then tin 4 bromide. Okay, so we have tin and +4, and bromide's a -1, so we'll need 4 of the bromides to balance things out. So it'd be SnBr4. Okay, let's move on here. Next series. Nomenclature. What are the names of AgBr? Okay, Ag is fixed charge, and so we call it silver. We wouldn't call it silver, in this case silver 1, because there's only 1 charge for silver, and that's +1. Bromide, there's only 1 charge for that. So this compound is called silver bromide. SiLver space bromide. Okay, tin, however, is a variable charge, and that's Sn. And we can tell what the charge is because we have 2 fluorides. Each fluoride's a -1, so that's a total charge of -2. Therefore, it has to be tin 2. So this is tin 2. Tin is a 2,4, so this is a lower charge. So this is tin, Roman numeral 2 in parentheses, space fluoride. Fluoride spelled F-L-U-O-R-I-D-E. Now, this one we would not call tin difluoride because, although tin is borderline, so that's one potential option, I suppose, is to name it as the binary molecular, since tin is a semi-metal. However, we were going to use the ionic nomenclature system for this, so it's tin 2 fluoride or stannous fluoride. Okay, iron is a variable charge. It's either +2 or +3. In this case, can you tell what it is? So what we have is 3 oxides. Each oxide is -2. And then we have 2 irons. So if each oxide is -2, that gives us a total negative charge of -6. That means the total positive charge has to be +6. And we have 2 irons, so each iron must be +3. +3 gives us +6. And so this is going to be iron, Roman numeral 3, oxide, or ferric oxide. Iron's a 2,3. And then finally, that brings us to copper. Copper is also variable charge. In this case, we can tell the charge on copper because of the chloride. We have 2 chlorides, each of -1. That gives us a total charge of -2 on 1 chloride. On 1 copper, we have to have a total charge of +2. So that's going to be the copper 2, Roman numerals, chloride. And in the old nomenclature system, that would be known as cupric chloride. Cupric chloride. Again, with these ionic compounds, we do not use the prefixes. So, for example, iron 3 oxide, we wouldn't call it diiron trioxide, and copper 2 chloride, we wouldn't call copper dichloride. That would be copper Roman numeral 2 chloride and iron 3 oxide. Let's see. Okay, let's move on to 24. What are the names of MnF3? MnF3, that's Mn's manganese, F, that's going to be fluoride, and so fluoride's a -1, so that's going to be manganese 3. Manganese Roman numeral 3, in parentheses, fluoride. Okay, nickel and sulfur. Sulfur is a -2, therefore that nickel must be a +2. And I mentioned that nickel is a variable charge, as a 2,3 cation. I know the supplement had it mixed up because on one page they called it fixed charge, on another page they called it variable charge. So we'll just call it variable charge. So that would be nickel Roman numeral 2, in parentheses sulfide. And then we have lead. Okay, here we can figure out the charge on lead based on oxygen. We have two oxides. Each oxide is a -2. -2 plus a -2 gives us a -4. That means lead has to be +4. So that's going to be lead, Roman numeral 4, oxide. Lead 4 is a higher charge, so that'll be Plumbeck oxide. And then finally, the cobalt. There are two ways to figure out the charge on cobalt. One, we look at the total negative charge. For example, we have sulfides, 3 sulfides gives us a total negative charge of -6. Our total positive charge must be +6. So we're going to get +6 from 2 cobalts. That means each cobalt is a +3. So it's going to be cobalt, Roman numeral 3, Roman numeral in parentheses, and sulfide. Okay, that would be another way of figuring out the charge is by reversing the cross multiplication. And so you can see we had 3 sulfides, but that 3 came from the charge on cobalt, and then we have 2 cobalts, and that 2 comes from the charge on sulfide. That works unless we simplified it to get it to empirical form, which isn't applicable in this particular problem here. Okay, let's move on here. Number 25. How do you recognize the formula of an acid? Well, acids always have the same cation or the same initial element, which is hydrogen. So acids would have a hydrogen. Begins with an H. Not always, but usually begins with an H. So that's not a law by any means. And the other elements are nonmetals. So that's one way. And acid anions are determined by, they begin with H and they have a negative charge. Okay, what element is present in all acids discussed in this chapter? H, hydrogen, is present. But when we say what element is present in all acids discussed in this chapter, like HBr, it's not hydrogen H2 that we're talking about, it's hydrogen, the atomic hydrogen H that we're talking about. In some acids we'll have 2 hydrogens, some acids will have 3 hydrogens, and other acids will just have 1 hydrogen. And so, by coincidence, if we have 2 hydrogens, like in oxalic acid has the formula H2C2O4. It's not hydrogen gas trapped in oxalic acid. It's just that we have 2 atoms of hydrogen in every molecule of oxalic acid. Okay, 27. Write the names and formulas of the 5 ic acids. That must be memorized before learning the acid nomenclature system. Cengage and Krakolici has a different system than me. My system for ic acids is all ic acids come from ides, not ides, sorry. Hydroic acids come from ides. All ic acids come from eights. And so any 8 anion, for example, perchlorate is ClO4 minus, and if you form the acid, it's HClO4. HCl4 is going to be called perchloric acid because it's the perchlorate anion. So I don't use his system of memorizing these, but we can see just as examples what happened with the nomenclature here. Carbonic acid comes from carbonate, CO3 2 minus. Nitric acid comes from nitrate, NO3 minus. Phosphoric acid comes from phosphate, PO4 3 minus. Sulfuric acid comes from sulfate, SO4 2 minus. Chloric acid comes from chlorate, ClO3 minus. And then we take those anions and then add hydrogens. In this case, we need 2 hydrogens for every carbonate because carbonate's a -2. And so this H2 is not hydrogen gas. This is just 2 atoms of hydrogen for each carbonate, or 2 ions of hydrogen. Nitric acid, this nitrate is -1, so we only need 1 H plus. Phosphoric acid is a -3. Phosphate is a -3, so we need 3 hydrogens to balance out the charge. Sulfuric acid, sulfate is a -2, 2 hydrogens, and finally chlorate is a -1. So it only needs 1 hydrogen. So the number of hydrogens is what's required to balance out the negative charge on the anion. Okay, let's move on. Which of the 5 memorized ic acids serves as? Okay, let's skip that one here. Let's go on to fill in the blanks. Okay. Sulfuric acid, ic acid, it's not a hydro. If it's a hydroic acid, it would be ide. Amic acid is an 8. So it's got sulfate, and so it's going to be sulfate's -2, 8, so we need 2 hydrogens, H2SO4, the answer there. I'm going to blow this up a little bit. Okay, when we look at the anion here, the anion's carbonate, or CO3 2 minus, anion's going to need 2 hydrogen cations, so it's carbonate. Carbonate makes carbonic acid. Chloric acid's got to be chlorate, which is a Cl3, ClO3 minus, and so it's going to be HCl3. Hydrogens +1, chlorate's -1, so HCl3. HF, now we're going to name this as an acid since they're talking about acids here. If it were HF gas, we'd probably call it hydrogen fluoride gas, which is a dangerous gas. Since if it's aqueous, we call it it's an ide. Fluoride with a D, so it's going to be hydrofluoric acid. AQ or HF gas will be hydrogen fluoride again. Bromic acid, it's got to be bromate. Bromate is a 3 oxygen, 8, and it's a -1 charge, so BrO3 minus, and so HBrO3 would be the answer to this one, HBrO3. Okay, H2SO3. Well, sulfate is SO4 2 minus, therefore SO3 with a 2 minus charge must be sulfite. Now, ites get the -ous acid ending, so this would be sulfurous acid. Unlike sulfuric acid, sulfurous acid is what we got here. Arsenic acid. Arsenic acid has got to be arsenate. Now we can get that from the pattern of the periodic table. Phosphate's a PO4 3 minus, arsenic's right below it, so arsenate must be an ASO4 3 minus. With 3 minus charge, we're going to need 3 H pluses, so it's going to be H3ASO4. Let's see, H3ASO4. HiO4. Okay, IO4 minus. Well, we know what iodate is. Iodate is 3 oxygen with a -1 charge, so IO3 minus is iodate. Therefore, IO4 minus would be periodate. Periodate, it's an 8, so it's going to be periodic acid. So we change the ending to ic acid here, the 8 to ic acid. Selenous acids. Selenous, ous acid must be ites, ITE. So this has got to be selenite. Selenite, well, we have to think, what is selenate? Okay, selenate's in the inner block, 4 oxygens, 2 minus charge. So selenate is SeO4, 2 minus. So selenite must be SeO3, 2 minus. And so it's got to be H2 SeO3. Now we have TeO3. Tellurium is right below selenium, and so this has got to be tellurite. Tellurate has got to be TeO4, so this is tellurite. Tellurite is going to get ous acid, so this is going to be tellurous acid. Tellurous acid. Hypoiodous acid. Well, what is hypoiodous? Hypoiodous is ous acid. Ous acid means it's an ite. And so it's got to be hypoiodite. Hypoiodite. Hypoiodite, well, iodate is IO3 minus. Iodite is IO2 minus. Therefore, hypoiodite is IO minus. So here we go over here. IO minus would need 1 H, so we get HIO. Bromate is BrO3 minus, bromite is BrO2 minus, and finally hypobromite is BrO. So this would be hypo, and it's an ite, so it's ous acid, hypobromous acid, which would be HBrO, hypobromous acid. Telluric acid, well, it's going to be tellurate. Tellurate is going to be a TeO4, 2 minus. That would be H2TeO4. Okay, there we go. Finally, HBrO4. HBrO4 is perbromate. BrO4 minus. Perbromic acid would be the answer here. Hydrobromic acid. Hydroic acid must be bromide. And so it's going to be HBr for this one. HBr. Okay, I'm going to stop here and break up the video into portions. So this will be part one. We'll continue after that.